last session of this edition, and it's an amazing speaker, Woody Zuill. So a little introduction about Woody if you don't know Woody. Woody has been programming for almost 40 years and spent much of that time working on legacy code, as you would expect. So hopefully he has learned something useful that he can share with us. You probably know Woody because of his reference of mob programming, and you can tell he has a lot of experience doing that. And personally, I told you that I practiced mob programming the first time with Christophe before, and today I'm working at the company at BuzzBud, and I introduced them to mob programming and remote mob programming, and so I'm always looking at Woody's stuff to get inspiration and best practices and things to try, etc. So today Woody is gonna tell you how you can use mob programming to deal with existing code together as a team. So that's your turn, Woody.
Alrighty, so we are beginning the presentation. Excellent. So yeah, I'm Woody Zuill, and I love to program code. I've been writing software for almost 40 years. I started late in my life, but I was very compelled when I first started learning to program about how effective it could be. And I solo programmed for about 15 years before I ever worked with another person. They introduced pair programming, people like Kent Beck, at the end of the 90s. I heard about it, I tried it, I liked it. Took me a few years to get good at it. At the same time as I was learning about refactoring, I was learning about test-driven development. All of those things have now become staples in allowing me to work well. So what I'd like to share with you is the idea of mob programming, along with the idea of how do we work with legacy code with mob programming. And I think I could end the whole talk right now because really legacy code is just what we work on no matter what. All of the code we work on is legacy code. As soon as we have something that's valuable to us and we don't want to break it, we've got it working, but we're now working with legacy code. We have to be careful about what we do. We have to pay a lot of attention to the nature of the fixes that we make and so on. So let's take a look. What's really important to me, I should say, is that we understand the nature of teamwork. Of course, whenever I give one of these talks, I want to warn you, I'm just sharing with you some ideas that I have. I'm not trying to tell you what to do or how you should work. I'm just telling you how I've worked and some ideas I've used. If they're useful to you, fantastic. And if they're not, such is life. So, but I want to make that clear right from the start. I'll use the word should, we should do this, or you could do that. But I really am just sharing you some ideas. This whole thing of mob programming started for us at a place called Hunter Industries in San Marcos, California. But the roots of it are much deeper than that experience. That was in 2011 when we started working this way. But we're going to find there's a whole lot more to it than just that. Mob programming, the basic idea is all the brilliant minds working together on the same thing at the same time, in the same space, and at the same computer. Now, this is a very simple concept that it's really what Agile was about. The people who wrote the Agile Manifesto understood, in my opinion, they understood that we need to collaborate more than we had typically been doing in the 90s. So what do we do about that? And they started pair programming, having very frequent meetings, having very frequent deployments. These meetings were to get us in alignment, pardon me. And with things like pair programming, we stay in alignment. At least the two people who are sitting together stay in alignment during the entire session. And so this idea just expands itself out. If we take the whole team and put them in front of a computer, then they can work as a team and stay in alignment or stay communicating with each other all the time. It's a powerful thing. The basic idea is we're going to get all the skills and knowledge together that we need to do whatever work is at hand so that we don't need to go off the team to go find somebody else to ask a question. So we don't need to go off to somebody else to figure something out or deal with some dependency. We have everything we need sitting there together as we do the work. You can see in this picture, This is sort of what it looks like from the front and from the back. But essentially, this can also be done remotely. A lot of you are doing that right now. As a matter of fact, I know dozens, if not at least 100 or more teams personally that are working really well remotely doing mob programming. Here's a picture of us, me doing this late last year or sometime last year, working remotely with a team. We were 2 different continents, so to speak. It seems crazy. How could this possibly work? It just doesn't seem to make sense. And like I said, I worked 15 years as a solo programmer. Over time, that just became my preferred way to work because that's the way I worked. I practiced working as a team. And I mean, as a solo programmer, I practiced working alone. But once I started discovering how good working with other people was, I had to learn a new set of skills. And pair programming was the beginning of it, but it grew into mob programming. Now at Hunter Industries, there is at least 7 or 8 teams working this way. They've expanded from the one team. But I'm going to show you a set of pictures here that this is being done all over the world, and it's not as preposterous or crazy as we might have thought originally. I'm just flipping through these quickly so you can see a whole bunch of different ways of working together as a team. They've got, every place has got its own setup. I like this picture. Hopefully you're seeing the same one I'm looking at. This is Grace Hopper. In 1960, I was just a young boy at the time. I never got a chance to talk to her. So somehow they figured out that working together was useful for them. And I think that's not uncommon, in a lot of work. But as you can see, these are very many different groups with very different styles. You might recognize a couple of the people in this picture, including Christoph, who just spoke a couple sessions ago. Christoph, this is, I think, the software craftsmanship group in Paris. I've been in that room. I didn't take this picture. I wasn't there when this picture was taken, but I've been to that room. It's a wonderful thing. They're doing essentially something like mob programming. Another group in France will go on. There's a group in Japan. And to close this off, I'm going to show you a few teams working remotely real quickly. So you can see this is being done in many different modes and in many different ways. And that kind of leads me to want to share with you that there is no hard rule to how you do things. Just learn how to work well as a team, work well together. Come in each day looking for a way to contribute that makes it easy for others to work with you. And you'll get a lot of benefit out of that. I like to show this picture of NASA. When we talk about remote, these people are a bit more remote usually than we are. When they've got a spacecraft out in, near the moon or whatever, wherever they might be, they're working in an extreme remote environment. But even in this room, they've gathered together all the knowledge they need to manage this mission control. Let's go on. Why would we work this way? I usually do this as an exercise, but I want to just tell you what people normally come up with. You can see here's a group of people working together. Why would we work this way? One of the primary things is there's a lot of knowledge sharing, and this is building our understanding of things. We get a lot of continuous code review and design review. This isn't a limited activity anymore because we're all seeing all the code that's being created. And that's, again, a very powerful thing. Oops, I got to click on something else here to get this to work. There we go. We get many ideas from the many different people who are all looking at this at the same time. So we're no longer limited to what we can contain in our own brain, but we get all the ideas from everybody as we work. Now, not all the ideas, I should say all the pertinent ideas. We get very rapid feedback. As we write something, if the product owner, the tester, the database expert, the coders are all sitting together, we get all these different points of view to get feedback from it. Almost immediately as we try things and run the code and so on, we start focusing on the right thing. This allows us to get higher quality. In other words, we no longer get distracted by things that aren't important. And when you have 5 or 6 people working together, we get to the important stuff rather directly. It leads us to better solutions. What we found is that we eliminate queues and we reduce inventory. We'll talk about that more later. This enhances the flow of the work. Overall, for me, we found that it was more fun, less stressful, and more engaging. So I'll just warn you, if you find by working this way that it is more stressful, Figure that out. Don't just accept it that it's going to be more stressful. Figure out how to make it easy to work with each other. Learn how to listen to each other. Learn how to talk with each other. Learn how to use the whiteboard to diagram things. Learn how to share your ideas and learn how to understand the other people's ideas. We'll talk a little more about that later if we have some time. I want to kind of keep skipping ahead and dealing more with the legacy code stuff. I do want to share this though. Why would we work this way? Because the team decided to work this way. It's wonderful to be given the opportunity to work this way. And at this particular environment, we essentially were allowed to find our own best way to work. And that's how this came out. So when the team decided to do it, there was nobody that could tell us, don't do that, or nobody would tell us, no, you should work this way. We decided for ourselves by experimenting what would work best for us. We were learning to pair program, and this team was learning to do test-driven development. We were learning how to interact well with each other, and we ended up doing mob programming. It turned out to be what we called it was mob programming. But originally, I just called it team programming. But let's go on a little bit. The concept is that we're going to optimize for the flow of the work rather than for the output of the individual. And when I relate this back to legacy code, when I first realized how valuable this is, I'm going to relate that back because we were working on legacy code at a company several years before we basically stumbled upon this way of working. This isn't about speed. Right now, I like to think of it this way. It's like we're shortening the race or we're shortening the distance. We're not going faster because we don't need to go as far. When we work this way, we get to go directly from idea to completed working software that somebody's using. And if you think of it as a bug fix or working in legacy code or wherever you want to do it, we're going to get more directly to the result we want. So this isn't about going faster. It's about having to travel a shorter distance. The basic idea is we don't want to try to get the most out of each person. That's sort of a false economy. We're trying to get the best out of each person. And this is a much more powerful, much more useful concept. Really, at first for us, understanding that was very important. We didn't feel as busy. We felt less busy, but we were more productive or more effective. So basically, it's not 5 people walk. I'm saying basically a lot, aren't I? Somebody should get a bleeper and bleep out every time I say basically. It's not 5 people watching one person coding. It's 5 people or 6 people coding together. This is a different way of thinking. We originally I learned pair programming with this thing called Driver Navigator, but it almost always turned into something I would call Driver Observer, where the person with the idea takes the keyboard and they're the one doing the typing. So they have the idea in their head, they're putting it in the keyboard as well, and this is a very, I would say, difficult form of communication. But along the way, I learned another way of working, a better way of Driver Navigator, where we actually have 2 people, and the navigator is going to share the idea of what we're doing, and the driver, the person with the keyboard, will simply transcribe that or translate that into something the computer can understand. I'm not going to go too much into details. In a longer introduction to the process, I would do that. But essentially, the idea is going to go from somebody's head into the computer by going through someone else's hand. This makes it a much better communication. We have a much better understanding. Rather than sitting there trying to figure out what somebody's typing, we're kind of guiding that typing so we all have a good understanding. So let's skip ahead a little bit here. The driver navigators worked well also with mob programming. We have the driver and a bunch of navigators, and we use that same idea. For an idea to go from someone's head into the computer, it has to go through someone else's hands. And this has a very full level of communication across the entire team, which can include, and hopefully will include, at least the tester, the coders, the product expert, and maybe whoever else we have the knowledge that we need. Whoever else has the knowledge that we need. I want to change my clip here. Let me do that. Hopefully my sound is working well for you. If it's not, well, such is life. So basically, there I said basically again, this is the way it works, but you can find other ways to do it. We have the keyboard, a dumb input device. We sit a driver in front of it. The driver is a smart input device or a mechanism. The navigators is everybody on the team, and they're there because they have the knowledge that we need to do this work. Whoever's at the keyboard can be rotated, and we would use a timer to do that when we were working. That's just one way to do it. And as they work, somebody takes the keyboard, the others start directing them. They say, well, let's try this thing, and off we go. As we do it, everybody that is sitting there has a chance to take the keyboard if they want to, but that's not the important thing. The important thing is we're having the discussions and we're interacting with each other as we do this work. We're coming up with the better ideas. So the driver's basic job is to be a smart input operator. They're gonna keep their eye on the code. They're not going to stay in the conceptual space of the problem and solution. That's where the navigators will be. This helps the navigators stay in flow, and it can easily block the flow if we're not careful. If the navigator's constantly trying to interject their ideas or explain why something won't work, it slows things down. You wouldn't want your keyboard doing that to you. So let the compiler, let the tests guide us. There's no rule, though. You do what works best for you. Essentially, I like to think of the driver as being a peripheral to the computer. They're part of the computer rather than part of the team for that short amount of time while they're at the keyboard. We switch the person at the keyboard out pretty frequently, and therefore everybody really spends most of their time as a navigator. The navigators are going to remain in the same context, and this allows us to share the cognitive load. We no longer have to keep everything in our own brain because we have other people with their own expertise there helping us. This is really powerful. This is actually extremely powerful. If you get good at this, you'll realize you'll have a more relaxed day. You don't have to keep everything in your own brain. The database expert's going to have the database stuff in their brain. You don't need to understand all of that. The front-end person, the tester, and so on, they'll be taking care of their expertise. This frees you up to truly apply your own expertise, whatever that happens to be. We're going to dialogue quite a bit. We're going to be talking. We're going to be diagramming. We're going to be listening. We're going to use visual communications like the whiteboard. And when we're online, we're going to use some kind of visual tool that allows us to work online that way. This gives us a shared memory location where everybody on the team can refer to that to understand where we're at and where we've been and where we're going. When we have that shared memory space, we now don't need to repeat ourselves so much. We can just point, or we can say, we're going to do this card now, or we're going to move this, we're going to do this little task, whatever it is. We've got the diagram. I'd love to show you some pictures of that, but for today, we're going to skip forward. We're going to be sharing and integrating our ideas in real time. Joshua Karievsky, who wrote the book Refactoring to Patterns, he thinks of mob programming as being a way of continuous integration of ideas. I love that thought. We need to learn, though, to contribute the right thing in the right time and in the right way. That means we don't share all of our ideas. We learn to share the relevant ones. And as we learn to interact, we learn better how to share those ideas. So I'm going to talk about the roots because this is deeply involved in legacy code. So when I'm giving presentations or workshops on working with legacy code, I'll usually ask this question. And a lot of people will, remember this thing that Michael Feathers said: legacy code is simply code without tests. I think that's one element. What we would normally see in a slightly larger context is that people will say that legacy code is code that someone else wrote sometime in the past. Well, we're not going to work on code someone wrote in the future, at least not yet. And it's hard to work on. So here's the thing. Somebody else wrote could be us yesterday. Legacy code could be code I wrote yesterday. It's in the past, which usually means we start to forget about it. But if somebody else wrote it, we maybe never even saw that code before. So we have to figure this out, and it's hard to work on. I like to think of it this way, because I think, probably somebody else has already explained this today, but, the word legacy can be used to mean, something you've been inherited, some property or money that's been left for you. It's something some ancestor put together, and now I get to get the value of it. That's valuable to me. I've been given this investment or this piece of land or this code, and it's working and it's making money for the company. And this is how I like to define legacy code. Legacy code is code that exists because it's bringing us value. I honor the person who wrote that code that brought us value. We want to keep it in working shape, and so we work on it. That's why we have it. I want our code to be easy to work on, and often legacy code isn't, but I don't think that's a quality of legacy code. Legacy code can be very easy to work on if it's properly tested, it has good tests in place, if it was written in a way it's easy to read, and so on. So basically, I will ask, I've got to quit using that word basically. Just cross that out every time you hear me say it. Essentially, we'll use a replacement word. I will do this exercise to get this groundwork. If we ask ourselves, what makes it hard to work on this code, we can come up with a long list. I have about 200 items on my list. I'm just going to show you a few of them here. I'm not going to go through them. There's all kinds of things, improper scoping, long methods, large classes, an antique architecture that's no longer relevant, horrendous coupling, dead code, code without tests, old development environments, code languages that are no longer secure, all kinds of stuff make working with legacy code difficult. So what do we do about this? So if we understand how code gets this way, I'm going to share just one idea. But essentially, when we start on a project, it kind of could feel like this. We're on a tightrope, but the tightrope is really near the ground. So as we balance on it, there's very little danger of falling off. We just get back up, fix the thing, and off we go. But over time, day by day, the difficulties we've introduced into our code are raising that tightrope. It starts feeling more and more uncomfortable, more and more difficult. I got this from Scott Ford, by the way. Sometime by the time it gets here, even the person who wrote this code in the first place is very uncomfortable changing things because it breaks stuff. And but somebody new to the project, when they come in at this point, it probably looks more like they're way up here because they don't get it. Why did you make this decision? How does that thing work? Where can I find the dependencies for this stuff? Sooner or later, it's off the top. So I'm going to share with you now where, to me, working as a team doing software development started. This was back in 2005 or 6, probably right in there somewhere. The scenario was that we had 2 million lines of code. It was the third rewrite of a software project that had already been around for about 15 years. And this particular version of it had been around about 3 or 4 years. There were many, many active clients that depended on this for running very large companies that made a lot of money for them. This software was important, but it had become unmaintainable, and the customers weren't happy with that. There were 500 open bugs, but there had been 500 open bugs since the day I arrived on the project after it had gone live. They just never could get rid of the bugs. It's like I used to call it fibs. Every time you fix a bug, every time you fix a bug, you introduce a bug. So fixes introduce bugs. And so this was not just fixes, it was enhancements and so on. And they weren't able to get rid of them. There's reasons for that. I'll talk about it in a bit. But they were going to replace this with a rewrite. They were going to rewrite the whole thing in a new language. You're familiar with that. There was going to be a skeleton crew to maintain it. And this is an interesting thing to me. What they wanted to do is move all the bright programmers to the new project and just put some of us maybe not, more like average programmers, just to maintain the thing. But we were charged with the ideas that we needed to keep the customers happy. They had to feel they were being supported. They had to feel that we were paying attention to their problems and working on them and improving it. But it was more of a facade. Can we just make them feel that things are getting better as they worked on the new version of the project? That would, of course, theoretically solve all the problems. Of course, it didn't in the long run. So we needed to do some minor enhancements and improvements along the way as well, just to make sure the customers felt they were being paid attention to. So this is what we did. First of all, there were about 40 or 50 developers working on the original project. They were all moved off of it. We were put with a skeleton crew of 6 people. We took this book, Lean Software Development, from Mary and Tom Poppendick. The very first day, I handed that out to the 6 people on the team, including me. I said, let's read this over the weekend, come back with a few ideas of what you want to try, and we're going to do as good a job as we can with this skeleton crew. And the first thing we decided to do was a value stream map. With a value stream map, you can determine what's bringing you value and what's not. And what we noticed was there was a lot of queuing in the managing of the bugs that we were trying to fix. And there was a lot of queuing in the fixing of the bugs. So there was lots of round trips, lots of stuff, and a lot of waste. And with the value stream map, your goal is to reduce the waste. Let's eliminate the queuing. But we also noticed there was a lot of inventory in managing these bugs. And not only was there a lot of inventory in managing the bugs, there was inventory in fixing the bugs. So these are the things that I want to be considering right now as we go forward. But this is what we did. We got out another book. We read a couple things by Kent Beck and another book that just come out, Working Effectively with Legacy Code by Michael Feathers. And we decided to pick a few of these things to become our way of working. And one is pair programming. Another was refactoring. So pair programming means we're going to work as a team. We're going to be refactoring as we go, rather than just fixing the bugs. We're going to introduce tests when and however we can. And we're going to work with this team of 6. Now, there was no idea of mob programming then. We were going to pair program. But almost immediately, we started working in 2 teams of 3. And each team looked like this. There would be a tester, a developer, and what they called a business analyst, which is like a product owner. In 3 months' time, we fixed all but 17 of those 500 bugs. And those 17 were essentially not fixable for legal reasons, bookkeeping reasons, and so on. We supported the customers with the minor enhancements and new functionality, and we kept them happy through this whole time. What 40 or 50 developers couldn't do over a 3 or 4 year period, we did in just a few months. And it was a really amazing thing to watch happen. We were learning to do solo work, but as a team. In other words, the work we used to think you needed to divide up and give to individuals to work on, we were now doing as teams. These were small teams of 3 people. Essentially, I was working as the driver, and the tester and the business analyst would work as the navigators. I then didn't need to learn anything about the business nature of the application or how to test it or where the bug might be, because the testers usually could guide me to that. So this was quite an interesting enhancement to the way I used to work when you work solo. You have meetings, you go off alone, you try to figure out where is this bug, and you need to try to learn what can I do to prove it's not working. I need to be able to learn what should it do, and all of that is in other people's brains. We have lots of meetings to do it. When we all 3 sat together, we got through it very directly. In this 3-month period, we were fixing on average about 4 bugs per day. Now, we didn't end up fixing 500 bugs because when you got 500 bugs, there's lots of duplicates. So I would say maybe half the bugs got fixed by fixing some other bug. And so this is just the way it went. So we were eliminating the queues and inventory. This is really critical to me. We were introducing the concept of flow. Flow is a very, very powerful thing. We won't have time to go into that too much, but once that effort ended, that application was very easy to maintain, and we moved on to the new project. And what we found in that new project was there was already legacy code. We'd been 3 months off on this side thing, getting this thing into shape, and now all this new code was turning into legacy code. As soon as we have something working, we want to keep working, then we've got legacy code, in my opinion. So anyways, we put together this thing we call the refactoring team. We weren't given the opportunity to do this during our work hours. We picked to do it during lunch. We would all sit together in a room. There were 6 of us. It wasn't the same group, but we used the same basic idea. We're going to sit at the computer with one person at the keyboard, and usually for the entire period, 1 hour, and we're going to pay attention to what's going on, and everybody will contribute their ideas. So this wasn't exactly mob programming, but it's real dang similar. So why would we work this way? I talked about that earlier. We were getting all these benefits. Now, this is back in 2006 or 7 now, where we moved on to working with this refactoring team. And this was not our regular work. It was something that we introduced as we moved forward in this new project. Let's keep this code as clean as we can. Well, once I left that place, I ended up a year or two later, 2009, however, is when my job there ended. Because well, I won't go into details, but a lot of us remember there was an economic downturn at that time. And I was able to work with a couple people, including Llewellyn Falco, who I got the idea from him where for something to get into the code from my brain, it needs to go through someone else's hands. We were together at a conference, and he had just been to another conference where he was introduced to the idea of the coding dojo. And he showed me 3 or 4 different ways to do the coding dojo, and I really enjoyed it. And the way that I picked up on most was to have the 5 or 6 people sitting at one computer. It worked extremely well. I want to talk about technical debt. We've heard a little bit of this already. This is the way that I'll say it. You know, remember the old days? We talk about reports and the work that our computer can do. And we used to say garbage in, garbage out. So if you have bad data coming in, no matter what you do with it, it's going to be garbage. But I think with technical debt, what essentially happens is garbage in and garbage stays. So we've got garbage there, and we're ingesting this garbage, and it stays in our code forever. So we want to get rid of that somehow. I'm just going to give you one example of how working with legacy code this way really helps to think about the nature of working as a team. Well, basically, I'm going to share with you. Somebody needs to put up a red flag for me every time I say basically. So this is one aspect of it. We have similar problems, but different solutions. And the reason we sometimes get this is because we are not looking at all the problems. So we could have 3 different problems. It's going to look like this. Here's a problem. Here's a similar problem. Here's a similar problem. This can be bugs. This can be new features. This can be enhancements, whatever you want to call it. But typically, each bug or thing is assigned to someone else to work on. And so we only see a few of these. If we were to all work on this together, we would all see the patterns here. We would all be able to see everything that's happening in each one of these. But since we're working on it separately, because some people believe that if we separate things and then have people work on it, we're going to get more done. That's not been my experience, but that's the belief. And of course, it's hard to change people's beliefs. But essentially, the first person, let's say, is an extremely proficient, very good coder, and they come up with a really nice solution to whatever it is they're working on. The next person is okay, but their thing's a little more convoluted, a little bit crazy. Maybe way too many dependencies. Nothing's been decoupled well, whatever. The third person is like this person who sort of comes up there. They're in left field most of the time. Their solutions, nobody understands. They're the only one who can work on their code, and their solution looks something like that. So this is basically, there we go. This is where we usually are when we're working on our project. When we work as a team, this is what I see. We bring the team together. We get that first thing to work on. We're all going to become familiar with it. But because everybody's working on it together, we get the best that this group can do. When the next problem comes along, we now can review it, and somebody's going to say, because we're a team, hey, that's got some elements of this other thing we worked on. And then we find we can extract something out, and that's the only variable part that we need to deal with, and we can use that same pattern for the second problem. When the third problem, or the third time this comes along, we really know the pattern, we understand the pattern, and we instantly jump to the solution that worked for us. Now, it doesn't have to be the only solution, but this is what we end up doing. Things get clearer because we're working with these patterns. We understand the patterns. Pardon me, I'm just going to check my clock to see how we're doing. Somebody's going to have to tell me when it's time to stop, or I'll just go on forever.
No, don't worry. You still have like 5 minutes if you want.
Okay, I can easily use up 5 minutes. So this is what I like to think of. Technical debt or technical debt free. So we get the technical debt because we're working on things separately. We can eliminate a lot of it if we're working on things together. Now that may or may not work for you, but this is what I've noticed. When a bug gets reported, in this other, in the technical debt world, we don't expose it in a lot of places. We're just going to see it in this chunk of code. But if what drove us to this is what we've ended up with is a kind of duplicate code because everybody's It's the different solution to the same problem. We're going to see this bug manifest itself at different times. But when we have it with the technical debt-free approach, then that bug will get fixed in all places if we understand it. What basically happens is we see it again, but now the changes that need to be made in the by this other coder are quite a few. And in this one, they're all over the place. And whenever we see that we have to make too many changes, somebody's eventually going to say, we need to rewrite it. And who needs to rewrite it? Well, it might be the person who wrote it in the first place, because everybody else says, we don't understand that code. And then they're setting off and rewriting it, and it often ends up being even worse than what they originally started with. This is a pattern I've seen many times. That's why I can speak confidently about it. So I'm going to start wrapping up so we can go to some questions and answers if we have time for that. The basic element underlying all of this is that we have a continuous learning environment. If we have a continuous learning environment, we're going to improve our skills and abilities over time. What we noticed for ourselves was we have to have a learning attitude. We have to allow ourselves to make the mistakes. This is a picture of me and my mom when I was a kid. She was baking a cake, and I came in and I said, hey, Mom, I want to learn to bake a cake. And she said, sure. So I worked alongside of her. And as we wrote this or made this cake, she said, well, the next thing to do is to mix it. So I got the mixer out and put it in there, and the cake mix went all over the place. And my mom laughed, and she said, oh, yeah, that happened to me the first time I used one of those. This, remember, was in the days when these things were hardly just invented. And so, you know, she had the attitude that if I tried the thing and made the mistake, and as a matter of fact, she said, let's figure out what went wrong. And the first thing she said is, let's clean up. She was real good at teaching me to clean up. I never really learned that, but she always insisted on cleaning up. And then she said, let's get out the effing manual. And we just got, and nowadays you go to YouTube and just watch a video. We got out the manual and I read the instructions. Oh, you got to do it this way so the stuff doesn't go all over the place. This is the learning attitude. You got to try things to learn, and you're going to make mistakes, and you learn from the mistakes. Don't ridicule each other for it. My mom was pretty good at that. Give me a chance to make the mistake. Let me figure out how to fix it. And under her guidance, I would learn. On the other hand, sometimes the junior person can teach the advanced person. When we're working with legacy code, we're often trapped in whatever knowledge we have. And the more junior person often has more knowledge than we have as an advanced person, because they're looking at it from a very different point of view. So I encourage us to work forward with this learning attitude. I think we're going to wrap it up right there. There's a lot of skills we need to learn. We'll do another talk some other day about that. But there we go. I hope that you learned something from that.
Thank you very much. Yes, I think that was super insightful, and I can also speak from experience that yes, junior developers are often afraid at the beginning because they think I will slow you down, and it turns out they make us learn so many things because they have a fresh view on the code. That's amazing. We do have a few questions that are coming in, so we'll pick the first one. How would you suggest justifying mob programming to project owner, manager, customers when it comes to cost?
Yeah, this is a tricky one. I would say the people that we need to justify to need to learn how to manage things. So you're not going to have a good opportunity to justify it to them if they haven't yet learned how to manage things. This is essentially about flow, and what they're managing for is productivity. And productivity is it's a misdirection. It's something that we do because we think that that's going to be useful, but in reality, productivity is not something we should be. That is not something which should be a goal for us. Effectiveness is what should be our goal. How can we become effective? Not how can we become productive. Most people who believe you need to separate people and have them work separately don't realize there's a huge cost, because we've broken our ability to communicate easily and well and to grow our understanding. So I have no way that I know of that I can convince an old style manager that this could be effective. So I look for working with people who already kind of get these ideas. If you find yourself having to justify this, A good course might be to just get better at working well as a team, however you can do it, and maybe take every opportunity. You can tell your manager that we're going to get together for a learning period. We've got this thing we want to learn, or we're trying to investigate this new package we want to work with, or whatever. I don't have any real good advice, but if your managers are feeling, hey, this is not going to be effective. I showed a dozen pictures or more at the beginning. There are people all over the world doing this. These are teams that are managed, so to speak, by people who understand that collaboration is more important than dividing the work up to hand it out to individuals.
Yeah, that's
I do
sure.
a whole talk on flow. I have a talk that I give on flow. You can find on if you search YouTube, and that explains some of the nature of that. But I don't have a lot of hope to convince managers. I'll put it this way. You've heard of Max Planck. Quickly paraphrase something he says in a lot more words, but he says, science advances one dead scientist at a time. So the basic idea is those scientists have to end their careers before the new ideas take root, because they're going to block them. And I'm afraid that's sort of the way it is with management. A manager who's stuck on managing in the old ways, they're managing to make it easier to manage rather than to make it easier to do the work. We should be managing to make it easier to do the work. And of course, let's stop there because I'll start yelling.
Oh, that's cool. We have another question, which is a legacy application more or less useful for the use of mob programming versus a Greenfield project?
A Greenfield project is legacy code after the first week. So we need to address that reality. Just because we're adding a lot more features than just working on trying to enhance something that's very difficult to enhance doesn't mean it's not legacy code. It's legacy code as soon as we have something useful that we want to keep working. Now, if we never get to that point, then we're just pretending anyways. So as soon as we have code that's working, we are working on a legacy project. We typically don't understand that. That's my opinion. So mob programming is good for any kind of work. Now, it's not the only way to work. You can still solo work and pair program. The team can dynamically join forces and separate as they feel they need to. But learning to enhance our ability to collaborate, learning to enhance our ability to work well together is going to serve us no matter what we end up doing.
Yeah, that's true. And from my experience, how we did that at BuzzBud, because we basically had the same question, so I can relate. And I just managed to get us get the team on board and try that for 2 sprints, so 1 month. And at the end of the month, we had to face the fact that we produced as much value. So it was not a problem of productivity, and the team felt better.
Yeah, I agree. I'll put it this way. With us, when we first started using what we officially called mob programming, we were getting a great deal more done once we started doing that. And we noticed that after just the first day. After a month or two, we realized, and we actually went back in our records to determine how much could get done, let's say a year before we started working this way versus a year after we started working this way. And we found we were accomplishing a great deal more of much higher quality code that was almost error-free, almost completely bug-free. So this, the value of it was very high. So if you're going to work in a way that improves your capabilities, you're going to get a better result. And a big part of what mob programming is about is that we're improving our capabilities as we go. We're getting a little bit of an improvement every day, whereas instead of every week or every 2 weeks, we're improving constantly.
And so final question, when you mentioned that you split into 2-3 teams, like QA, dev, analyst, how did you proceed with code reviews? Did you ask the dev from the second team to review your code?
We did no code reviews whatsoever. What we were doing was attempting to deliver into production, or at least into a production version that any customer could download and install, because in those days that's the way they were doing it. This was a huge project, and that was a big undertaking for any company. But when we fixed a bug they wanted to work with, they wanted to have fixed, they would do that. We didn't do code reviews. These were pretty straightforward bug fixes. But because Michael Feather's book had just come out, we were always at least using the Sprout method to fix these things, or Sprout class or something like that. So we could write unit tests around the bit we were fixing. And since I was sitting with a tester and sitting with the product owner, we quickly could verify, did we nail this or did we not? So if we, our main goal was just to keep the customers happy, and they were happy getting bug fixes that were important to them. So the quality of the code, as far as we were concerned, was being improved massively over what they had before, and they were not doing code reviews there before either. The code was really I like to say amongst the worst I'd ever seen, but I rarely go to a job where the code isn't amongst the worst I've ever seen. So that's because why would they hire me if they already had everything working nicely? But I was on that job for 6 years, so I would say it was a very difficult place to work, and yet that's where I learned, how do you influence change? We flew under the radar. Nobody knew what we were doing, and that we got to do that there because we were willing to work on the legacy stuff that everybody else wanted to get off of. So they were just happy that someone would take it, and that way, if something went wrong, they could blame us. But they just didn't even want to know what we were doing. That gave us a lot of freedom.
Well, thank you for sharing all of this.
Well, I hope that was useful to someone.
Yeah, I think it will be. Thank you, Woody, a lot for being here, for doing that talk, for sharing. If you want to talk further with Woody, I encourage you to go on Twitter, and connect. I think we're gonna wrap it up.